we will move to my presentation, and I'll start looking just in front of me, the Minister for the Environment and Energy of Greece. But I call him the Minister for Adaptation. We started a large project, a European-wide project, and NEO is part of it, because the Academy is part of it. It's a live project, so that's a happy announcement on the adaptation. And one may ask, what are the common things that are between Greece, Messinia, and Sweden? We are 10 million, you are 10 million. Our gross domestic product is about 200 billion, yours it's 500. We have invented democracy here, not far away at Pnyx, just above the Agora. And you have performed perfectly in applying the ideals and the ideas that have been put forward by all the ancient philosophers, particularly those of the classical and pro-classical times. But in addition to these common values and ethics and size, we live in the same planet, and we suffer or we benefit from the same weather situation. So the prevailing climate is determined by a number of factors that they either bring rain or shine. They can bring rain in Sweden, which is something that happens more often than what we have in Athens, in Greece in general. But there are these systems in the Atlantic Ocean which determine how much of rainfall, excess rainfall, or less rainfall will be falling in a given winter and a given rainy season, either in Sweden or in Greece. So the North Atlantic Oscillation has an index that shows how the weather systems, the high pressure systems or the low pressure systems do behave, how much they have been influencing in the past both rainfall, both in Sweden and in Greece. And you can see that there is a high correlation in Sweden and as well as in Greece. So, and the correlations, which means the relationship between two phenomena that may look quite distant, because the North Atlantic Oscillation, as the name is, the oscillation in the North Atlantic Ocean, which is far away from Greece. It is also away from Sweden. But yet, it has different footprint in Sweden than what it has in Greece. And in view of the global change that has been influenced by man-made activities, regardless of the opposition of the two relationships, we can see that we have a common future in a globally changing environment. For instance, in the past 100 years, these are observations, we have seen an increase in this North Atlantic Oscillation intensity or index, and a decrease which is larger in Messinia. It's larger in the western part of Greece. Messinia has lost about 25% of the total annual rainfall that it gets. And unfortunately, we can see that in the future, the tendency is that that North Atlantic oscillation will continue increasing and rainfall will continue decreasing in the western part of Greece. So, regardless of measures taken, this is a real threat because we get most of our water from the western part of Greece. And one can see that after the next or the other decade, we will continue with reduced rainfall falling in western Greece. Already we lost 25%. We estimate with our models that we will be losing another 20% by the end of this century. Now, I'm using here model calculations. They refer to the greater area, including western Turkey. And one can see that the southern part, in the worst case scenario of reduction of rainfall will be reduced by more than 30% in 100 years from now. Now, if one goes to temperatures, because of course rainfall and temperatures are decisive indices for climate change. So one can see that there is a high correlation between wintertime temperatures over Northern Europe, and particularly over Scandinavia. Greece's wintertime temperatures are not influenced so much. But the summertime temperatures are going up, and these are the estimates for the future with models. There is a medium scenario and a well done, I would use that terminology, scenario, the heated scenario. And there one can see the coincidence of our future. So we have a common future. We have rainfall that is determined both in Greece and in Sweden, same way, following the global destabilization of climate, and air temperatures that do show that Sweden will become warmer, much more warmer than what Greece will do. And here are the changes foreseen with our models. They are customized models for downscaled for this part of the world. I have put that slide to show you the long time series from Stockholm. These are departures from the mean temperature. It has to do with the winter time because the winter time is easier to determine in terms of the changes in the North Atlantic. And one can see here that in the past 200 and so years, temperatures have been going up at a pace of about 1 degree per century. And you can see here Stockholm, you can see St. Petersburg, Rome, and Athens. They all follow the same kismet, I may use. So we are facing the same kismet. And the longevity of the time series in Stockholm and in St. Petersburg gives us also some clues what has happened during the two great wars, the Napoleonic Wars, 1812 in Moscow, and Hitler's, or the Nazis' war in the winter of 1940, 41, 41, 42. And I have marked these years to show you that they correspond to the lowest temperatures recorded at St. Petersburg and Stockholm and Moscow. It is not shown here. And these two events have changed the course of history. Napoleon lost, and Hitler lost. So there are more common issues that are related to our common future. Relative humidity, for instance, is going down, and it is forecasted to continue going down. So aridity, but at the same time, an increase in the risk for forest fires. And as you know, last summer, we were having fires in Sweden. And 5 years ago, we were having huge fires outside of Moscow in the summertime. And we know that forest fires, we know that from Messinia fires, from work that has been done at NEO, they go at higher altitudes. So in the past, no measures were taken for adaptation at elevations exceeding, say, 400 meters above sea level. Now we need to go up to 600 or 1 kilometer above mean sea level. So forest fires are something that is a threat. We have something you don't have in Sweden. It's the seismic activity that is preparing the soil after floods or after extended periods of dry periods to lose soil. And this is why we have prepared this adaptation, which includes synergy and synergistic effects between all these factors that are shown in the slide. Notable here is the region of the area, the scientific area of agriculture. And we know that Messinia has one of the most beautiful. A late friend and colleague was considering that the olive tree forest in Messinia is the largest on earth and the healthiest according to Nikos Margaris. So, in fact, it would be a pity not to study this multi-interdisciplinary situation, which is a big challenge. And Mr. Kostandakopoulos, I want through you to thank the private sector that has been really interested to benefit from what we, the scientists, find in our laboratories. If it was not you and people like you, there would have been no competitive projects, no better knowledge, and no better hope for the future. Thank you very much for your attention.